The universe was born in heat, a radiant breath expanding into darkness. Yet far ahead lies a time when that warmth will fade. A time when stars no longer burn, when galaxies drift into silence, when everything softens into a final, quiet equilibrium. Tonight, we travel gently into that distant future, into the calm story of a universe growing cold. Welcome to AstraFlow. Here, science drifts like starlight, and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing find its rhythm, and your mind float through wonder. Before we begin, I'd love to know where you're listening from. Are you lying in bed under city lights, or watching the stars from somewhere quiet? Tell me in the comments. It's always peaceful to imagine the AstraFlow community scattered across the world, drifting together through the same sky. And if this calm journey brings you peace, you can gently support AstraFlow by liking this video or subscribing. It helps this little corner of the cosmos keep glowing. Now, let's begin tonight's voyage into the quiet story of the heat death of the universe. Imagine your breath drifting softly, rising and falling like waves of warmth, dissolving into the night. In the beginning, the universe was a storm of heat. Energy crowded every corner of space, moving, colliding, glowing. But even in that brightness, cooling had already begun. Heat always slips from warmer places to colder ones, flowing outward like water seeking a wider shore. For billions of years, stars have been small pockets of resistance against that cooling tide, islands of fusion pushing light into the darkness, yet each star is temporary. Each burst of starlight is a momentary shimmer. Slowly, gently, the universe loses these sources of warmth. Galaxies thin, suns fade, even the brightest regions soften over time. Heat death is not a sudden ending. It is a slow settling, a final balance, a state where warmth no longer has anywhere left to go. No gradients, no flows, just calm. If you picture the cosmos as an ocean, then stars are its glowing waves. Heat death is the moment that ocean becomes perfectly still. No ripples of heat, no currents of light, only quiet, endless equilibrium. And yet there is tenderness in this distant fate. The universe is not collapsing or breaking, it is relaxing, unwinding after an eternity of motion, resting after an age of brilliance. Tonight we'll drift across this timeline, from the last stars to the final black holes, from cooling galaxies to the universe's most silent moments. Not with fear, but with awe for the luminous era we inhabit right now. Let your breath soften, let your mind loosen. The story begins. There is a moment each night when the world around you softens, the air grows still, sounds fade, your thoughts loosen and wander. In that quiet, time feels different, not gone, just gentler, as if stretched into a slow, peaceful flow. The far future of the universe carries this same sensation, magnified beyond imagination. A cosmos where almost nothing changes, yet time continues drifting forward like a faint current under a frozen lake. It leads us to a question both scientific and deeply human. What does time mean when the universe grows nearly motionless? To answer, we return to the quiet rule behind everything. Warmth moves from hot places to cold ones. Your tea cools. Your body releases heat into your blanket. The day dissolves into the cooler air of evening. This simple flow, called entropy, is the arrow of time. It nudges every process forward. It shapes every spark, every fading ember, every soft exchange of warmth. Entropy rises because energy searches for balance. Not violently, not chaotically, but naturally. The way water levels out, or fog spreads through a room. Over cosmic ages, this drift toward equilibrium becomes the guiding narrative of the universe. Stars burn because fusion concentrates energy. Stars die because that energy eventually spreads. Galaxies form because matter clumps. Galaxies fade because their heat and motion disperse. And so, when we imagine the far future, trillions of years from now, we picture a universe where the gradients that define time have nearly vanished. Fewer warm places, fewer cold places, fewer differences for heat to chase. Motion slows, processes stretch, change becomes rare, not because time stops, but because nothing remains to push it. This is the path toward heat death, an ending that feels more like a long exhale than a final moment. You can sense the analogy in your own stillness. When you lie in bed perfectly quiet, breathing softly, the passage of time becomes hard to feel. Without contrast, as without activity, minutes blur together. Entropy is the cosmic version of that blurring. When all processes reach equilibrium, time loses its familiar texture. But there is beauty in this idea. It reminds us how precious our dynamic universe is, how extraordinary it is that stars shine at all, how rare it is to live in an age where change is abundant, where heat flows, where light dances, where life can emerge from the delicate imbalance of energy. As we move deeper into the story of the cosmos's future, we will follow this slow drift towards stillness. Not with sadness, but with calm appreciation for the warmth we experience now. Warmth that exists only because the universe is still full of motion and difference. For now, let the question settle quietly in your mind. If time continues even when change fades, what does that say about the nature of time itself? When we imagine the future of the universe, our minds often reach for sudden endings. A collapse, an explosion, a final curtain falling all at once. But the true future of everything is not a single moment. It is a long, gentle descent through eras so vast that human time becomes almost invisible. The universe does not end with drama. It stretches, softens, and slowly settles. Tonight, we unfold that timeline like a quiet star chart, tracing the cooling journey ahead. Right now, we live in the stelliferous era, the age of stars. Our cosmos is still rich with light. Suns burn steadily, galaxies spiral with luminous arms, and nebulae glow like cosmic embers. Heat moves energetically. Processes happen quickly. This is the warm, active chapter of the universe's life, and we inhabit it at a wonderfully bright moment. But even in this glow, the next steps are quietly forming. Star formation is slowing. The raw gas that once birthed new suns is thinning out. In trillions of years, only the smallest, longest-lived stars will remain, red dwarfs, glowing faintly like distant coals. They will outlast every other star type, shining patiently through epochs we struggle to imagine. This red dwarf era will be a calmer universe, lit only by soft sparks spread far apart. Far beyond that lies the degenerate era. Most stars will have faded into remnants, white dwarfs cooling into black dwarfs, neutron stars drifting in darkness, planets wandering without suns. Galaxies will still exist, but they will be dim, like old memories suspended in endless night. Then begins the age of giants that do not shine, the black hole era. With most matter quiet and cold, black holes become the dominant engines of energy. They consume what remains, shape the last flows of mass, and hold the universe's final gravitational structure. Yet even they do not last forever. Over unimaginable timescales, Hawking radiation will cause each black hole to evaporate, releasing its last whisper of warmth into the cold. And after that whisper, silence. The heat death era. Particles scattered across an expanding cosmos too far apart to interact. No gradients, no structure, no warmth to flow. A universe in nearly perfect equilibrium, not broken, not destroyed, but fully settled. Strangely, this future is peaceful. The cosmos does not fall into catastrophe. it drifts into rest. And understanding this journey makes our present moment, a universe bright with stars and warmth, feel even more precious. This far future map is the path we'll follow. A long, cooling arc, a gentle fading of light, a story not of endings but of quiet transitions. Heat is one of the simplest patterns in the universe, yet it shapes everything we see, from the glow of stars to the warmth of your own breath. It begins as a concentrated spark, a pocket of energy, and from that moment it wants only one thing: to spread, to drift, to soften. Heat always seeks balance, and in doing so it writes the long, gentle story of the cosmos. When you warm your hands by a cup of tea, the heat does not stay still. It flows outward into the cooler air. When sunlight touches your skin, its warmth diffuses into your body, then into the world around you. Every flow, every soft drift of warmth, follows the same natural rule. Energy moves from regions of high concentration to low, hot to cold, bright to dim, active to quiet. This simple tendency, the spreading of energy, is the foundation of entropy, and entropy is the quiet engine behind the universe's future. In the earliest moments after the Big Bang, heat filled everything. The cosmos was hot, dense, and uniform. But as space expanded, that heat stretched with it, thinning like warm mist drifting through a widening valley. Temperature fell, energy spread out, and from that cooling, structure began to form: atoms, stars, galaxies. Paradoxically, the universe needed to cool before it could shine. Later, as gravity gathered matter, new pockets of heat ignited. Stars flared into existence. Their cores fused hydrogen into heavier elements, releasing immense warmth back into the cosmos. For billions of years, stars have acted as small fountains of concentrated energy, temporary reversals in the universe's long cooling trend. But even these fountains eventually dry up. Their heat radiates outward into the dark, their fuel depletes, their structure collapses, and their light fades into the vast expanding cold of space. This is the life cycle of heat: a brief concentration, a long release, a brilliant surge followed by a slow, gentle surrender. The cosmos is full of such moments. From supernovae to the faint cooling of lonely planets, each event contributing to the great redistribution of energy. As the universe ages, fewer warm regions remain. Heat spreads farther, diluted by expansion. Eventually, even black holes, the universe's last energetic object, will evaporate, releasing their remaining warmth in a final whisper. And when all of these flows have finished, when every gradient has flattened, heat will have nowhere left to travel. The cosmos will settle into equilibrium, the calm at the end of heat's long journey. Yet in this science lies something quietly beautiful. Heat is motion. Heat is change. Without it, no star would burn, no planet would warm, no life would awaken. Every warm moment you've ever known is part of the same cosmic story, a temporary glow in a universe slowly learning to rest. As we continue, hold this image gently, warmth rising, fading and drifting into stillness. A universal exhale. Entropy is often described as disorder, but that image misses the softness of what it truly represents. Entropy is not chaos, it is balance. It is the natural spreading of energy, the quiet evening out of temperature, motion and structure. When something cools, entropy rises. When heat disperses, entropy rises. When a bright flame fades into warm air, entropy rises. It is the universe's way of smoothing sharp differences into gentle harmony. Imagine a patch of sunlight on your bed. At first, the warmth is concentrated. You can feel it on your hand, gentle and bright. But leave it for a few minutes, and the warmth blends into the room. The patch vanishes. The temperature evens out. Entropy has climbed, Not violently, not chaotically, just naturally, as if the universe prefers calm over contrast. On cosmic scales, that same drift guides everything. In the early universe, energy was densely packed, entropy was low, but as the universe expanded, energy spread out. Temperature differences stretched and thinned. Slowly, entropy climbed, not as a force, but as the natural direction of change. Stars formed because matter clumped, lowering entropy locally, but in the process of shining, they increased entropy overall, releasing vast amounts of heat into space. Even life participates in this climb. A living cell creates order within itself, but only by releasing more heat into its surroundings. Every heartbeat, every thought, every movement is powered by energy that must eventually dissipate. Life thrives on gradients, and entropy ensures that those gradients gradually fade. As we look toward the universe's distant future, entropy becomes the central storyteller. It tells us why stars burn out, why galaxies thin, why black holes evaporate, why the cosmos will one day settle into heat death. Not because something destroys it, but because the flow of energy has nowhere left to go. Entropy increases whenever a warm region cools. It increases whenever light travels through space. It increases simply because the universe expands, stretching every photon into a longer, softer wavelength. With each passing moment, the cosmos becomes slightly more even, slightly more balanced, slightly more settled. In this light, entropy is not a villain. It is the universe's slow drift toward rest. It is the soft slope that guides every process from motion to stillness. And though it leads eventually to a quiet, dimmed future, it also makes possible the vibrant present. The star above us, the warmth of the day, the spark of life. As the universe continues its long exhale, entropy will keep climbing, guiding everything toward the final equilibrium. And we, living in this brief, warm chapter, are small, bright fluctuations, islands of order surrounded by a cosmic sea that is slowly, gently smoothing itself out. Entropy climbs, but not with urgency. It climbs like dusk settling over a landscape, quietly, steadily, beautifully. Starlight is the universe breathing. Each star inhales darkness and exhales light. Each pulse of radiation is a warm sigh drifted across space, a release of energy from deep within a glowing core into the vast cool around it. When we look at the night sky, we are watching countless small breaths, scattered like embers on an endless shore. Inside every star, fusion presses atoms together, binding them so tightly that energy is freed. That energy travels outward through layers of plasma, then escapes into the vacuum as light and heat. The warmth you feel from the sun on your skin is a fragment of this exhalation, energy that began its journey hundreds of thousands of years ago in a dense, silent core, slowly migrating outward, then spilling across space until it found you. This flow of starlight is not just illumination, it is structure. It warms planets, shapes atmospheres, and fuels chemistry. It creates the gradients that allow life to emerge, warm surfaces, cooler nights, circulating winds, flowing water. All of these patterns are echoes of a star's breath. But breath implies rhythm, and rhythm implies time. Stars are not eternal. They inhale darkness and exhale light only as long as their fuel lasts. When fusion slows, their breath weakens. When fusion ends, their breath stops. The cosmos becomes quieter, one star at a time. As we travel forward through the universe's long timeline, starlight plays a diminishing role. The bright early epochs of cosmic history give way to an older, gentler era where fewer stars remain, spaced farther apart, glowing more softly. Eventually only red dwarfs, small, steady, patient furnaces, continue this universal breathing. They burn their fuel with astonishing efficiency, taking trillions of years to fade, like a candle protected from every draught. Yet even these final stars will one day dim. Their glow will thin, then vanish, leaving behind only remnants, white dwarfs cooling into shadow, planets wandering without warmth, and a cosmos increasingly shaped not by starlight, but by silence. In this gradual fading we find a quiet truth. Starlight is temporary, but its influence is vast. Every warm moment in the universe's history, every ray of sunlight on Earth, every glimmer in a distant galaxy is part of the same long exhale. Heat death is simply the moment when this breath has fully released, when the universe has exhaled all it can. For now, we live in a luminous chapter, a warm chapter, a chapter where stars still shape the rhythm of existence. The universe is breathing, and we are alive within its inhale and exhale. As starlight drifts outward into the great dark, it carries with it the memory of where it began, and the reminder that all warmth eventually becomes part of the cooling whole. There was a time, the time we live in now, when the universe was awash with light. Galaxies shimmered like floating cities. Star clusters burned like handfuls of sparks scattered across a velvet sea. Nebulae glowed with soft, colourful breath. This is the bright era, the cosmic age when starlight is abundant and the night sky is alive with shimmering structure. It is easy to forget how extraordinary this moment truly is, because it feels so familiar to us. But in the universe's long cooling journey, it is only a brief, radiant chapter. When you step outside on a clear night and look up, every star you see is a furnace releasing energy into the dark, a beacon in the great, cooling landscape of space. The Milky Way arches overhead like a river of light, each tiny point a sun burning through its fuel, each glow a reminder that the universe still has warmth to share. This era, filled with starlight, is a precious interval where energy is still concentrated enough to shape worlds and sustain life. In the early universe, stars formed in great abundance. Clouds of hydrogen and helium collapsed under gravity, igniting fusion in brilliant bursts. Galaxies churned with newborn stars, their spiral arms thick with glowing nurseries. Light was plentiful, and the cosmos glowed with youth. Energetic, dynamic, restless. But even in this brightness, decline has already begun. Star formation has been slowing for billions of years. The gas clouds that once fed cosmic creation are thinning. Galaxies are using up their star-making material, and fewer new suns are being born. Slowly, almost imperceptibly, the night is preparing to dim. The bright era is not defined by how much light exists, but by how much contrast there is. Stars shine because space is dark. Heat flows because the void is cold. Life thrives because gradients exist. Between star and shadow, day and night, warm surface and cool air. This balance is what makes the universe vibrant, and this balance will not last forever. Far in the future, as star formation dwindles, the skies will change. The Milky Way will merge with neighbouring galaxies, forming a single, massive, quiet structure. The number of shining stars will decrease. The universe will not go dark quickly. It will fade gently, softly, over trillions of years. This slow dimming is not tragic. It is natural. It is the universe aging, the way a fire burns brightest before settling into warm embers. And right now we are fortunate enough to witness its peak radiance. The cosmos is still luminous, still full of warmth, still alive with motion and contrast. We exist within the glow of this grand era. Every sunrise, every starry night, every shimmer of starlight reaching Earth is part of this fleeting brightness, a moment in the universe's long journey toward calm. Even in an age of brilliant starlight, the universe is quietly changing. The glowing arms of galaxies still swirl with beauty, but the cosmic nurseries that once overflowed with newborn stars are becoming thin and quiet. The raw material of creation, vast clouds of hydrogen and helium, has been steadily used, stretched and dispersed. And so, without drama, star formation begins its long, gentle decline. To picture this change, imagine a bustling city at dusk. Lights still shine in every window, but fewer new homes are being built. The energy remains, the movement continues, yet the growth has slowed. The galaxy feels similar, vibrant yet subtly easing into a calmer rhythm. For billions of years, galaxies were rich with cold gas, the essential ingredient for star birth. Gravity would pull these clouds together until they collapsed and ignited, forming stars of all sizes, massive blue giants that lived fast and faded quickly, and tiny red dwarfs that burned with steady patience. This cycle shaped the universe, adding warmth, light and structure wherever new stars appeared. But star formation is a consuming process. Each new sun locks away part of the galaxy's gas reservoir. Supernova explosions can disperse or heat the remaining gas, making it harder for new stars to form. Collisions between galaxies stretch gas into long filaments, scattering it into regions where it no longer gathers densely. Little by little, the conditions that once made starbirth common become rarer. Astronomers can already see the trend. Compared to its early life, the universe now creates stars at a far slower pace, a slowdown that has lasted for billions of years. The night sky looks unchanged to us because human time is too short to feel such vast transitions. But on cosmic scales, the universe is like a fire that has passed its brightest flame and is now settling into a long, slow glow. In the far future, this decline will continue until only small, hardy stars are still forming, and eventually even those final suns will stop appearing. Galaxies will contain stars, yes, but no more beginnings, no more ignitions, no more new sparks to replace the ones that fade. Yet this fading is not bleak. It is a natural part of cosmic evolution. The universe was born in fire, blossomed in light, and will age with grace. Every star that forms now, including our sun, is part of the closing movement of this luminous symphony. As star formation slows, the universe begins its transition into a quieter, older era. An era where starlight still shines, but creation slows its pace, preparing for the long journey into the deep future. As the universe grows older and star formation continues its gentle decline, a new era slowly takes shape. An era ruled not by brilliant giants, but by quiet survivors. Red dwarfs, the smallest and most enduring of all stars, become the guardians of cosmic light. Their glow is faint, their warmth subtle, but their patience is extraordinary. They burn their fuel so slowly that many will outlive the entire current age of the universe. To imagine the red dwarf age, picture a night lit not by the strong, golden warmth of a sun like ours, but by a dim ember glowing steadily in the dark. Red dwarfs are cool by stellar standards, shining with a deep red hue, their surfaces calm, their lifetimes stretching from trillions to even quadrillions of years. While massive stars blaze brightly and expire quickly, red dwarfs drift through time like gentle lanterns, conserving their fuel with remarkable efficiency. Most of the stars in the universe are red dwarfs, quiet workhorses of the cosmos, but in our era they are overshadowed by brighter stars that command the sky. In the far future, when the luminous giants and mid-sized suns have long faded, red dwarfs will remain as the universe's last constellation makers, holding back the darkness for ages far beyond human comprehension. During this long era, galaxies will look very different. The brilliant blue-white stars that once shaped spiral arms will have vanished. The overall glow of galaxies will dim, leaving behind a soft, ruddy shimmer. Solar systems around red dwarfs will drift in deep, steady twilight. Planets, if they exist, will orbit close to stay warm, basking in light that feels more like the last glow of sunset than the bright noon of a young star. And yet, despite their faintness, red dwarfs are stable. Their surfaces rarely erupt with violent storms. They fuse hydrogen slowly and gently, wasting almost nothing. While stars like our Sun live for about 10 billion years, many red dwarfs may shine for 1,000 times longer. In a universe slowly cooling, their persistence becomes a form of cosmic resilience. Eventually, though, even these patient stars will run out of fuel. Their light will fade to a dull cherry glow, then to warmth too faint to detect, and finally to darkness. Each red dwarf will become a black dwarf, a cold, quiet remnant drifting through space. But the red dwarf age is vast beyond imagining. It represents the longest sustained period of starlight the universe will ever know. Long after every familiar star has died, long after galaxies have dimmed into shadow, these tiny, steady embers will continue shining, offering the cosmos its final chapters of warmth and illumination. For now, let the image settle gently in your mind, a universe lit by faint, patient stars, a calm, enduring glow stretching across unimaginable time. There will come a time when the universe has only a handful of shining stars left. Not clusters, not constellations, not galaxies filled with glowing spirals, just scattered points of light spaced unimaginably far apart. These are the last burning stars, the final sparks resisting the deepening cold. Their glow will be faint, but in the vast emptiness of this late cosmos, even a small ember becomes a beacon. After the red dwarf age stretches through trillions upon trillions of years, those tiny patient stars will eventually exhaust their hydrogen. Their light will dim, their warmth will fade, and one by one they will slip into darkness. The process will be so slow that it makes all of human history feel like a heartbeat. A red dwarf may take 100 trillion years to reach its end, a number so large it becomes almost like silence. The last stars burning may not look like the stars we know today. They will be incredibly small, incredibly dim, and only barely warm, more like glowing coals than suns. Around them, planets, if they still exist, will experience a slow twilight that stretches for billions of years. Night and day will blend into a dusky reddish haze. The warmth sustaining those worlds will be fragile, a flicker against the backdrop of a universe steadily cooling toward equilibrium. As each of these stars fades, it leaves behind a remnant, a black dwarf, a star that no longer shines but still carries the memory of fusion deep within its core. These remnants will drift silently through space, too faint to be seen, too cold to shape the matter around them. They will form the quiet population of objects that inhabit the far future, relics of a universe that once blazed with brilliance. Between the last surviving stars, darkness will dominate. The Milky Way, by then long merged with countless galaxies, will no longer be a bright spiral but a sparse scattering of dying embers. The distances between stars will have grown so vast that light may take trillions of years to travel from one remnant to another. Space becomes a vast, lonely ocean, with only a few fading lanterns floating across it. And yet, there is a strange beauty in this final illumination. These last stars are like the final moments of a fire, the dim orange coals glowing softly in the dark. Their light is gentle, patient, and deeply peaceful. They flicker not with urgency, but with the calm acceptance of a universe completing its long, luminous chapter. When the last star finally cools, the cosmos will enter a new age, one without natural light, where heat becomes rare and motion becomes slow. But before that silence arrives, the universe will experience this brief, delicate twilight, marked by the final stars burning with quiet dignity. Stop here, breathe, and imagine the softness of that distant glow. Galaxies, once vibrant with starbirth and luminous arms, will slowly cool into quiet shadows. In our era, a galaxy is a glowing city of light. Clusters, spirals, nebulae, and rivers of starlight stretching across tens of thousands of light years. But as star formation dwindles and old stars fade, galaxies begin a long transition into darkness. Not abruptly, not dramatically, but gently, like a fireplace settling after its last log has burned. Imagine looking at the Milky Way far in the future. Its bright spiral arms have softened. The blue-white giants that once outlined its structure have vanished. The glowing clouds of gas that once formed new suns have dispersed. What remains is a dim, warm haze, the combined light of many faint red dwarfs and the soft glow of aging remnants. The galaxy still spins, still breathes in its slow rotation, but its brilliance has eased into a meditative calm. Galaxies cool because stars are their heat engines. Each star that dies removes a source of warmth, a point of light, a contrast against the cold. As the final generation of stars fades, the galaxy's overall temperature drops. Even the interstellar medium, the thin gas between stars, grows colder, losing energy to the expanding universe. Over trillions of years, these clouds no longer collapse into new suns. They simply drift, stretched thin by gravitational tides, suspended in an ever-cooling environment. In time, the galaxy becomes a collection of stellar remnants, white dwarfs cooling into black dwarfs, neutron stars resting in the dark and black holes quietly distorting the space around them. The luminous spiral we know disappears, replaced by a sparser, older structure, a shadow of its former self. Yet even this shadow remains graceful. It carries the memory of billions of years of starlight, the echo of countless suns that once illuminated its arms. The distances between objects increase as space expands. Galaxies that were once neighbours drift apart, their interactions slowing until each becomes an isolated island floating in the dark. The grand cosmic web, the network of galaxies and clusters, thins and stretches, its warm intersections slowly fading. Eventually galaxies cool so thoroughly that they no longer shine with visible light. They become quiet archives of cosmic history, holding the frozen remnants of everything they once created. And though they appear dark, they still move, slow, steady, unhurried, through a universe that is gently surrendering its heat. There is a profound stillness in this future vision. A galaxy cooling is not a tragedy. It is a natural settling, a final softening of structures shaped by ages of light. The universe is aging, but it is aging with grace. As we continue our journey, we will drift deeper into this cooling cosmos, through eras where darkness grows and warmth becomes rare, each step guiding us toward the quiet end of change. As the last generations of stars dim and galaxies cool, the universe enters a new chapter, one defined not by brightness, but by absence. Light still exists, but it grows scarce. Warmth still moves, but it moves slowly. In this era, the cosmos begins a long drift into darkness, a gradual fading that unfolds over spans of time so vast they soften into something like silence. Darkness in this context is not an emptiness to fear. It is simply the natural resting state of a universe that has spent its energy. When we look at the night sky now, it feels dark only because our eyes are tuned to the brightness of stars. But in the far future, even those faint pinpoints will vanish. One by one, as stars exhaust their fuel, they slip quietly into shadow, leaving behind remnants that no longer shine. At first, this fading will be subtle. Galaxies will still hold scattered red dwarfs glowing softly, their light just enough to outline the galactic shapes. But as trillions of years pass, these last stars will cool, and the galaxy's glow will thin like mist in the early morning. Eventually, there will be no visible stars left, only cold remnants drifting silently across a darkened stage. Planets, if they survive, will orbit nothing but memories. Worlds that once basked in starlight will become frigid spheres, illuminated only by distant background radiation. Their oceans, if they had them, will freeze into ancient ice. Their atmospheres will settle, still and unmoving. Any warmth they retain will seep outward into the vast cold of space, following the same cosmic rule that guides all heat. Even motion slows in this deepening darkness. Orbits stretch, galaxies lose their structure. Interactions between celestial objects become rare. The universe expands further, pulling everything into greater separation. Space itself becomes a quiet expanse where events unfold at a pace that feels almost timeless. Yet despite the encroaching darkness, this era holds a quiet beauty. There is something tender in the way the universe dims, not suddenly but gradually, like the last light of evening fading into night. The drift into darkness is not a collapse nor a destruction. It is the cosmos cooling, resting, and easing into equilibrium. For us, imagining such a future invites reflection. Our lives are measured in years and moments of brightness, days filled with sunlight, nights sprinkled with stars. To envision a universe without these familiar anchors is to face the immensity of time itself, the scale on which all warmth eventually settles into calm. As darkness grows deeper, the universe becomes quieter, not empty, not lifeless, simply still. A vast, gentle quiet, like a breath held at the end of a long exhale. Long after a star like our sun has exhausted its fuel and shed its outer layers, a quiet remnant remains, a white dwarf. These stellar cores shine not because they burn, but because they retain the heat of their former lives. They are the still glowing memories of stars, compact and brilliant, radiating away the warmth stored during billions of years of fusion. But even this glow is temporary. Over time, these remnants cool, dim, and eventually become invisible. This slow transformation from white dwarf to black dwarf marks another step in the universe's long drift towards stillness. A white dwarf is incredibly dense. A teaspoon of its material would weigh as much as a mountain. Its atoms, crushed by gravity, are locked in place, unable to collapse further because of quantum pressure. And yet, even in such extreme conditions, the dwarf radiates heat into space. It releases energy not in bursts, but in a slow, steady fading, like a coal glowing softly in the dark. At first, white dwarfs shine with a bluish-white light, brighter than any planet and nearly as radiant as small stars. But as eons pass, that glow weakens. The surface cools from millions of degrees to thousands, then hundreds. The light shifts from white to yellow, from yellow to red, and finally slips into infrared wavelengths too faint for any distant observer to see. This cooling is not fast. It spans trillions of years, but on the scale of cosmic time, even trillions are just steps in the grand descent toward equilibrium. Eventually, a white dwarf becomes so cold that it no longer emits detectable light. It becomes a black dwarf, a silent, invisible sphere of carbon and oxygen, drifting through a universe that has little warmth left to offer. Black dwarfs will be numerous in the far future. They will make up much of the mass in aging galaxies. Though dark, they will still be massive, still tugging gently on nearby remnants, still participating in the slow gravitational ballet of a cooling cosmos. But unlike stars, they no longer shape or illuminate their surroundings. They simply exist, quiet witnesses to the passage of unimaginable time. The idea of a black dwarf is poetic in its own way. It is a star that lived, shone, warmed worlds, forged elements, and then slowly released all its stored heat until none remained. What is left is not a failure, but a completion, a final settling, a perfect equilibrium. In imagining these darkened stars, we are reminded of cycles, how heat rises and falls, how brightness emerges and fades. A white dwarf turning black is not an ending to mourn, but a natural exhale in the universe's long journey toward calm. And in that exhale, there is peace. As stars fade and remnants cool, many planets will find themselves wandering through a universe without suns. Worlds that once circled warm, glowing stars will drift into darkness, their orbits loosened or entirely broken by gravitational shifts. These planets, lonely travellers without a sky, without day or night, become some of the quietest residents of the far future cosmos. A planet without a sun is not like the Earth we know. There is no morning to warm the air, no sunset falling over oceans, no gentle glow filtering through clouds. Instead, darkness surrounds everything, deep and absolute. The only light might be the faint shimmer of a distant galaxy, or the residual glow of the planet's own cooling core. But even that warmth fades with time, radiating into the cold until the world becomes still. Rogue planets, as we call them today, already exist. Many more will form as stars die, or as gravitational interactions eject planets from their solar systems. Over trillions of years, the universe will fill with such wandering worlds, each carrying its history silently across the void. Imagine standing on the surface of one of these planets deep in the far future. The horizon would be completely black, except for rare pinpoints of distant starlight, and even those will disappear as the last stars fade. The ground beneath your feet would be frozen solid. Any atmosphere it once had might collapse into liquid or ice, settling low and unmoving. The planet's core would still hold warmth, but that warmth would escape slowly, year after year, until even the deep crust cools into silence. And yet, despite the darkness, these planets are reminders of how complex the universe once was. Each one represents a solar system that formed, lived and transformed under the warmth of a star. Some may have hosted oceans, weather, chemistry, or even life. Others might have been barren but beautiful, deserts illuminated by red dwarfs, icy moons orbiting gas giants, volcanic surfaces glowing under tidal forces. In the distant future, all planets share one fate: to cool. Their internal heat disperses into the expanding universe, their surfaces contract, and their once dynamic landscapes settle into motionless forms. They become ancient stones drifting through infinite night, carried only by the quiet pull of gravity. There is a strange calm in imagining these rogue worlds. Though they no longer orbit suns, they follow the same cosmic rule as everything else. Heat flows outward, energy spreads, and eventually all things find stillness. Even without light, they remain part of the universe's story, the drifting punctuation marks in a cosmos that is gradually losing its warmth. Planets without suns are not lonely in a sorrowful way. They are simply settled, carried gently through the dark like leaves on an endless silent river. As the universe grows older and colder, even the graceful motion of orbits begins to change. Today, planets circle their stars with elegant predictability. Moons follow their planets, and stars dance around their galactic centres. These motions feel eternal to us, steady, reliable, unbreakable. But over the unimaginable timescales of the far future, orbits slowly unravel, guided by faint but persistent cosmic forces. Gravity holds systems together, but nothing in the universe is perfectly still. When two objects orbit one another, they exchange tiny amounts of energy, almost like breaths passing back and forth. Normally, these exchanges are too small to matter, but over trillions of years, even the faintest interactions echo through time. Stars encountering one another in a galaxy can nudge orbits gently, sending planets drifting away from their original paths. Rogue stars, passing quietly through the outer edges of solar systems, can disrupt the delicate balance, loosening gravitational ties that once seemed unbreakable. Even the slow expansion of the universe contributes, stretching distances and gradually weakening the bonds that hold systems together. In the far future, these small effects accumulate. Planetary orbits become unstable. Some planets drift outward, escaping their stars altogether and becoming wanderers in the dark. Others spiral inward, falling slowly toward the remnants of their stars, faint white dwarfs, neutron stars, or even black holes. The collapse of these orbits is not violent. It unfolds with glacial patience, like a leaf circling a pond drain in slow, widening spirals. Binary stars, too, may tighten their embrace over time, shedding energy through gravitational waves, ripples in space-time that carry momentum away. As energy leaves the system, the stars drift closer, orbiting faster until they eventually merge in one final event before cooling into darkness. Even black holes can follow this path, spiraling together in collisions that briefly ignite the universe with gravitational light before fading into silence. On galactic scales, orbit collapse happens even more subtly. Stars within a galaxy interact through countless tiny gravitational tugs, slowly diffusing their orbits. Eventually, galaxies themselves lose coherence. Stars wander farther from their origins. Structures blur. What was once a bright, defined spiral becomes a faint cloud of remnants drifting apart. This long unwinding of motion is part of the universe's journey toward equilibrium. As orbits collapse and systems disperse, energy redistributes more evenly. Motion becomes less structured, less dynamic, more still. Over time, the universe forgets its once intricate choreography. There is a quiet sadness in watching these motions fade, but also a deep peace. The collapse of orbits is not destruction. It is release. It is the final softening of patterns shaped by billions of years of gravity and light. A cosmic unwinding, slow and tender, guiding the universe toward the calm that awaits in its distant future. As stars fade, planets drift and galaxies cool into shadow, one type of cosmic object will continue shaping the universe long after nearly everything else has grown still. Black holes. They are often imagined as devourers, dark and violent, yet in the far future they become something quieter. The last engines of structure, the final beacons in a universe losing its light. A black hole forms when a massive star collapses under its own gravity, compressing matter into a region so dense that nothing, not even light, can escape. In the present-day universe, black holes coexist with bright surroundings, glowing accretion disks, swirling gas, heated material spiraling toward the event horizon. But in the distant future, when starlight has waned and gas clouds have thinned, black holes will sit in relative solitude, their intense gravity shaping whatever remnants drift near them. They are in a way the universe's final sculptors. While stars once carved landscapes of light, black holes will carve the last patterns of motion, bending stray planets, capturing wandering remnants, and merging with one another in immense slow dances that ripple space-time with gravitational waves. Even when all stars have dimmed, a black hole's presence can still release energy. When matter falls in, it heats to extraordinary temperatures, emitting bursts of radiation before crossing the horizon. These events become rare in the far future, but not impossible. Occasionally, a drifting remnant, a planet, an asteroid, or a black dwarf will wander too close, producing a brief flash of energy in an otherwise dark cosmos. These flashes are not bright enough to light galaxies, but they are among the last active processes capable of producing heat. Supermassive black holes at galactic centers will remain the giants of this era, continuing to influence their surroundings long after galaxies have faded. Their gravitational pull will quietly organize the orbits of remnants, even as the universe expands and structures loosen. Over unimaginable spans of time, these giants may merge with others, each merger sending a final echo through the fabric of space-time. Yet even black holes are not eternal. Stephen Hawking's discovery that they emit a faint radiation, now called Hawking radiation, means they slowly lose mass. Very slowly. A supermassive black hole could take 10 to 100 years or more to evaporate, outlasting stars, galaxies, and most forms of matter. In the deep future, these giants will be among the last objects capable of releasing energy into the cold. For now, imagine them as dark lighthouses, not shining outward, but influencing the universe through their gravity, shaping the last motions of matter. Their presence is subtle but enduring, a final reminder of the cosmos's once vibrant structure. In a universe drifting towards stillness, black holes are the last beacons of activity, the final guardians of motion before even they too fade into the quiet. In the deep future, when starlight has vanished and galaxies no longer shine, black holes linger as the final keepers of cosmic motion, yet even they are not eternal. From their dark edges, something faint leaks outward, a soft, almost imperceptible glow. This glow is Hawking radiation, the quiet whisper through which a black hole slowly releases its energy back into the universe. Hawking radiation is unlike any light we know. It does not rise from heat or fusion or fire. Instead, it emerges from the delicate fluctuations of empty space itself. Even in perfect darkness, the vacuum is never truly still. Tiny pairs of particles blink into existence, then vanish again almost instantly. Near a black hole's event horizon, these pairs can be separated. One falls inward while the other escapes, carrying away a small amount of the black hole's mass as energy. The result is astonishing. A black hole that slowly evaporates. But slowly does not begin to capture the scale involved. A black hole with the mass of a star might take 1067 years to disappear. A supermassive black hole could take 10 to 100 years or more. These numbers are so large that time loses its familiar meaning. They stretch beyond the lifespan of galaxies, beyond the era of stars, beyond even the dissolution of matter itself. Hawking radiation is a process that unfolds in the faint twilight of the universe's final ages. To imagine this whisper, picture a coal cooling in a vast empty desert. Long after the fire has died, the coal still emits a faint warmth, losing energy grain by grain, molecule by molecule. Now extend that image across unimaginable scales of time and space. A black hole behaves like that coal, except instead of glowing visibly, it radiates with an energy so faint it would be undetectable until the cosmos is almost completely dark. As the black hole evaporates, it shrinks. Its event horizon contracts. With less mass, it radiates faster, and the whisper becomes a subtle crescendo. In its final moments, the black hole releases a burst of energy, a last exhalation into the silence. Then it is gone. What remains is a soft dispersal of particles drifting outward, joining the thin sea of radiation that fills the late universe. When the last black hole evaporates, a profound shift occurs. The universe loses its final source of concentrated mass and energy. No more accretion, no more mergers, no more gravitational fireworks. What remains is a cosmos of isolated particles and fading warmth, yet there is something peaceful in this ending. Hawking radiation is gentle, patient, and inevitable. It ensures that nothing, not even the darkest objects we know, lasts forever. Everything flows, even in the emptier stretches of time. In the quiet whisper of Hawking radiation, the universe continues its slow journey toward equilibrium, releasing its final reservoirs of energy into the growing dark. There will come a time when even black holes, the most enduring structures the universe has ever known, reach their final moments. After ages beyond imagining, after every star has faded and every remnant has cooled, the last giants of gravity will continue to shrink under the quiet influence of Hawking radiation. Their existence, once defined by immense power and darkness, will end not with a dramatic collapse, but with a faint and gentle release of energy into the cold. Imagine a universe almost completely empty. The galaxies have long since dissolved. Stars have disappeared into memory. Matter exists only as scattered particles drifting through an expanding void. In this vast stillness, black holes remain as the final anchors, their gravity shaping the few threads of motion left in existence. Yet even they cannot escape the slow whisper of quantum mechanics. Over incomprehensible spans of time, they lose mass grain by grain. At first, the change is imperceptible. A black hole's evaporation is so slow in the early stages that it seems frozen, unchanged across trillions of years, but the process accelerates as the black hole becomes smaller. What begins as a whisper gradually grows into a soft hum, then a quiet crescendo. Near the end, a black hole that once outweighed millions of stars becomes no larger than a mountain, then no larger than a pebble. Its event horizon shrinks to microscopic scales. The radiation it emits grows hotter, brighter, more intense. In its final fraction of a second, the energy releases in a burst, a last exhalation of the universe's stored heat, and then the black hole is gone. Nothing remains but the gentle spray of particles drifting outward, quickly cooling into the background. The end of each black hole marks the closing of a chapter. For billions of trillions of years, they were the universe's final engines, shaping the motion of matter long after stars had fallen silent. Their last bursts of radiation are the final sparks in a cosmos that has steadily surrendered its warmth. When the very last black hole evaporates, the universe will have no remaining sources of concentrated energy. No more fire, no more fusion, no more collapses or mergers or cosmic storms. What remains is a thin sea of low-energy particles spread across an ever-expanding space, a universe fully committed to stillness. The gradients that once drove motion, light and heat have flattened. Entropy has approached its maximum. Change has slowed to almost nothing, and yet there is a calm beauty in this quiet ending. Black holes do not vanish in violence. They complete a long journey of transformation. They return their mass to the universe in a final, gentle offering of energy, joining the soft background that will define the cosmos for eternity. The universe, in losing its last black holes, enters its most peaceful state, an existence shaped not by fire or motion, but by silence. When the last black hole evaporates, the universe enters a phase unlike any before it, a realm where almost nothing larger than a subatomic particle remains. Galaxies, stars, planets, and all familiar structures have long dissolved. What fills the cosmos now is a delicate sea of particles, photons drifting with almost no energy, neutrinos wandering endlessly, and the occasional proton or electron, each separated by distances so vast they may never meet another particle again. This is the universe at its quietest, a place where motion still exists but so faintly that it feels like a whisper. The grand architecture of earlier eras has given way to something simpler, almost serene, a cosmos reduced to its smallest ingredients, spread thin across ever-growing space. To imagine this era, picture standing on a shoreline at night, watching waves fade into ripples and then into still water. The sea does not disappear. It simply loses its contrast, its motion, its power. What remains is a calm surface reflecting the emptiness of the sky above. The universe, in this distant future, resembles that still water, a smooth expanse where nothing stirs strongly enough to create structure. The particles drifting through this cosmic sea carry the last remnants of energy from ages long past. Some were released in the earliest moments after the Big Bang, others escaped from dying stars. A few are the final breath of evaporating black holes. Now, with no sources of concentrated heat left, these particles simply glide outward, their wavelengths stretched by the expanding universe until they hold only the faintest trace of warmth. Interactions between particles become exceedingly rare. The universe has grown so large and matter so sparse that collisions may occur only once in unimaginable spans of time, if at all. Chemistry, fusion, and the complex dance of atoms no longer take place. Even gravity's influence weakens as distances stretch. Structures no longer form, nothing clumps, nothing ignites, nothing collapses. And yet, despite this near-total quiet, the universe is not dead. It is simply resting at a scale beyond anything life could witness. Energy still exists, but it has settled into the most even distribution possible. Motion persists, but it no longer shapes or transforms. Space expands, but the expansion carries no heat, no new patterns, only the steady thinning of what remains. There is a gentle peace in this vision. After cycles of creation and destruction, brightness and shadow, growth and collapse, the cosmos has settled into clarity, a sea of subatomic calm where entropy has nearly reached its peak. The drama of earlier ages has softened into stillness. The universe is no longer a stage for stars and galaxies, but a quiet field of drifting particles, each one carrying a memory of the light that once filled everything. This serenity is not tragic. It is the natural end point of a long journey, the universe's final, quiet exhale. In the early universe, structure was everywhere. Galaxies formed intricate spirals, stars clustered like shimmering dust, and planets assembled from the gentle pull of gravity. Even subatomic particles arranged themselves into atoms, molecules, and the astonishing complexity of life. But in the far future, long after stars have cooled and black holes have evaporated, structure begins to dissolve, not suddenly, not violently, but through a slow, inevitable softening, as the universe drifts toward a state where nothing new can form. At this stage, space is vast beyond comprehension. Matter is sparse. The distances between particles have grown so large that the forces once binding them, gravity, electromagnetism, even the strong nuclear force, become less meaningful. An atom sitting alone in this darkness feels almost no influence from anything else. Its bonds are stretched thin by expansion. Its particles vibrate with almost no energy. In this stillness, structure begins to lose its definition. Imagine holding a sandcastle on your palm. At first, it is crisp. Delicate towers and tiny walls, each grain part of a larger shape. But if you gently blow across it, the structure softens, edges blur, grains drift apart. The castle remains sand, but no longer holds the form it once did. The cosmos experiences something similar on a scale far beyond imagination. The very building blocks of matter begin to behave not as pieces of structure, but as isolated grains in an endless thinning sea. Some theories suggest that protons themselves may eventually decay, dissolving into even simpler particles over timescales of at least 1034 years, and possibly far longer. If this happens, the universe will lose its last stable pieces of matter, leaving only lighter particles such as electrons, photons, and neutrinos drifting through space. Everything that once had texture, stars, worlds, atoms, becomes a faint memory encoded in a whisper of radiation. Even if protons do not decay, expansion alone stretches the universe until interactions become almost impossible. No new stars form, no molecules assemble, no atoms collide. Without energy differences, without density changes, without gradients, the universe cannot build anything new. It cannot evolve in the ways it once did. Structure dissolves because the conditions for structure vanish. This dissipation is not destruction, but release. The universe is letting go of complexity, unwinding the intricate patterns it once held, reducing them into a simple, quiet state where nothing resists equilibrium. There is a gentle humility in this idea. Everything that ever formed, stars, oceans, nebulae, living beings, depended on a delicate imbalance of energy. When that imbalance fades, so does complexity. The universe is not broken, it is completing a cycle. a long arc from simplicity to complexity and back again. In this great softening, the cosmos becomes almost pure silence, a place where structure relaxes into nothingness, and every particle moves through space without intention or connection. As the universe drifts deeper into its far future, even the most fundamental structures begin to loosen. In earlier ages, gravity held galaxies together, nuclear forces bound atoms, and electromagnetism shaped molecules and life. But in the long twilight of the cosmos, these bonds, once firm, once essential, begin to fade. This era is marked by a profound softening, the unbinding of everything. At first, the unbinding is subtle. Stars no longer form, so gravity's great engines weaken. Galaxies, stretched by expansion, lose the tight spirals and dense clusters that once defined them. Over trillions of years, their shapes blur. Remnants drift outward, no longer held in familiar patterns. The web of cosmic structure, so intricate in its youth, becomes a faint shadow. But deeper unbinding may wait at the level of matter itself. Some theories propose that protons, the stable cause of atom, may not be eternal. If proton decay occurs, it unfolds over unimaginable spans of time, far longer than the lifespan of any star. A proton may take 1034 years or more to decay, quietly releasing lighter particles as it falls apart. Should this be true, every atom in the universe will eventually dissolve. Carbon, oxygen, iron, all the building blocks of stars and life, will slowly vanish, leaving behind only a mist of simpler particles. Other theories suggest the opposite, that protons are perfectly stable. If so, matter will not disappear, but it will still lose connection. The distances between particles will grow so vast that atoms rarely meet, rarely interact, rarely collide. At this scale, even stable matter becomes functionally unbound, drifting silently through an expanding sea with no meaningful structure remaining. Regardless of which path the universe takes, the outcome is similar. The ties that once created stars, planets, chemistry, and life fade into nothingness. The familiar hierarchies of structure, atoms forming molecules, molecules forming cells, cells forming living beings, unravel. The energy that once animated cosmic complexity becomes evenly spread, leaving no gradients to drive change. Imagine a woven tapestry slowly losing its threads. At first, patterns remain, though thinner and looser. Eventually the fabric disintegrates, leaving strands where intricate art once existed. The universe undergoes a similar transformation, not destruction, but quiet unweaving. And in this unweaving, there is a certain peace. The cosmos is not collapsing violently or tearing itself apart. It is relaxing, releasing the tension held in its structures, returning to simplicity after an age of extraordinary complexity. What began as a dense, fiery expansion blossomed into galaxies, stars, planets, and conscious beings capable of wonder. Now, in the farthest reaches of time, everything loosens, everything softens, everything drifts. The unbinding of everything is not an ending to fear. It is a return to the most natural state of the universe, calm, balanced, unstructured, and free. Time, as we understand it, depends on change. A clock ticks, a planet turns, a heartbeat pulses, a star burns. Each motion gives time texture, a rhythm we can sense. But in the deep, far future of the universe, when structure dissolves and energy differences flatten, change becomes rare. Processes slow to a crawl. Events stretch across spans so vast they feel almost still. In such a cosmos, time itself begins to lose meaning. Right now, time feels steady. The Earth spins once every 24 hours. The sun rises and sets with comforting predictability. Stars evolve across millions or billions of years, long by human standards, but still dynamic on cosmic scales. We mark our lives by cycles, Mornings and nights, seasons and years, each anchoring time to motion. But imagine a universe where nothing moves in any noticeable way, where atoms rarely interact, where the last remnants of heat drift outwards so slowly that billions of years pass without measurable change. Time continues, yes, but without contrast, without events, without motion. It becomes more like an endless horizon than a flowing river. In this late stage of the cosmos, entropy has nearly reached its maximum. The gradients that once powered stars, weather, chemistry, and life have faded. Without differences in temperature or energy, time has no direction to push processes forward. The arrow of time, once tied to the cooling of the universe, becomes almost imperceptible. It is like sitting in a perfectly quiet room. At first, you hear your breathing, the faint hum of distant sounds, the rhythm of your heartbeat. But as you settle, as silence deepens, seconds can stretch, minutes can blur. Without sensory changes, time feels softer, less anchored. The universe experiences something similar, but on a scale so vast that even the word vast feels inadequate. In this era, a single particle drifting through space may travel for 1 trillion years without encountering anything. An event that once took a fraction of a second might now require ages. Processes that defined earlier cosmic epochs have dissolved. The universe is no longer a theatre of rapid change, but a calm field where motion slows towards stillness. And yet this fading of time's meaning is not frightening. It is peaceful, like a deep meditation where thought softens and breath becomes almost imperceptible. The universe is not breaking, it is resting. It is settling into a state where time's passage no longer needs to be measured, because nothing resists the calm. When time loses meaning, the cosmos reaches a kind of quiet purity. Not emptiness, but serenity. Not silence, but equilibrium. It is the final smoothing of a universe that once burned with brilliant activity. A long cosmic exhale that brings everything into balance. In the beginning, the universe was anything but smooth. It surged with density variations, tiny ripples in temperature and energy that later grew into galaxies, stars, and planets. These uneven places, warmer here, cooler there, gave rise to everything we now know. Structure was born from contrast. Motion arose from imbalance. Light flowed because darkness existed beside it. But in the distant future, after stars have faded, after black holes have evaporated, after matter has thinned into a sparse sea of drifting particles, the universe approaches a state of remarkable uniformity. Temperature becomes nearly the same everywhere. Energy spreads evenly. Gradients flatten. This is the smooth universe, the final stage of cosmic evolution. To imagine this smoothness, picture a once roaring ocean settling into perfect calm. Waves disappear. Ripples soften into stillness. The surface becomes so even that sky and water blend into one continuous horizon. The cosmos, too, reaches such a horizon where variation is almost non-existent and motion no longer creates new patterns. In a smooth universe, heat no longer flows meaningfully because there is no warmer or cooler place for it to go. A photon travelling across space carries so little energy that it barely interacts with anything. Particles drift without forming bonds. Processes that once defined cosmic time, stellar burning, gravitational collapse, nuclear reactions, have all ceased. This uniformity is the natural result of entropy's long climb. As energy disperses over trillions of years, differences diminish. What once drove change becomes evened out into equilibrium. Without contrast, there is no engine for new structure. Without gradients, there is no direction for time to express itself. The universe becomes a vast, gentle sameness, a stillness that has taken eons to achieve. And yet, this smoothness is not emptiness in a negative sense. It is a kind of peaceful completion. The universe has travelled through cycles of fire and turbulence, creation and destruction, brilliance and shadow. It has formed stars and worlds, life and consciousness. Now, at last, it rests in a balanced state where nothing strains or pulls. In this smoothly spread energy field, the cosmos reaches a form of quiet clarity. The story of creation and collapse has ended, not abruptly, but with a gradual softening, like music fading into silence. What remains is the final equilibrium, the most relaxed state the universe can achieve, and perhaps there is beauty in this idea. After an existence filled with movement and contrast, the universe settles into a serene, almost meditative calm, a calm that does not require structure to be meaningful. A calm that reflects the natural tendency of all things to seek balance. The smooth universe is the cosmos at peace, unchanging, unhurried, and endlessly tranquil. In the earliest moments of the universe, photons were everywhere, a radiant flood of energy filling space with light. As the cosmos expanded and cooled, that light stretched, softened, and thinned. Some photons came from the Big Bang itself. Others were born in the hearts of stars, in the glow of nebulae, in the flare of supernovae, and in the faint whisper of evaporating black holes. For billions upon billions of years, the universe was shaped by these particles of light. But in the far future, after stars have vanished and black holes have exhaled their final bursts of energy, only a few photons remain. These last photons drift through a universe so vast and empty that they may never encounter anything again. Their journeys stretch across unimaginable distances, their wavelengths stretched by the expansion of space until their energy is almost non-existent. Each one becomes a ghost of the brightness that once filled the cosmos. To imagine the last photon, picture a single spark drifting across an endless, cold ocean. It has no destination, no companion, no barrier to reflect from or warm. Its energy is so faint that it carries almost no information about where it came from. And yet, it continues, because photons always move, unstoppable in their quiet persistence. As space expands, the wavelength of each photon stretches. A particle of light that once glowed with visible colour becomes infrared, then microwave, then radio, and eventually so long wavelength that it is almost indistinguishable from the fabric of space itself. These photons are still there, but their presence becomes more symbolic than physical. They are echoes of a universe that once shimmered with brilliance. The idea of a last photon is poetic rather than literal, because photons decay not by disappearing, but by losing energy until they blend into the background. Over infinite time, each photon's energy approaches zero. It becomes part of the smooth equilibrium that defines heat death. Motion without meaning, light without brightness. In this far future, the universe no longer generates photons. It only remembers them. Every photon present is a relic, a survivor from an earlier age. They carry the final imprints of cosmic activity, the stretch of expansion, the fading glow of matter, the last sighs of evaporating black holes. The last photon is not a moment or a milestone, but a gradual fading, a soft transition into perfect stillness. When the energy of the remaining photons becomes so low that no process can be driven by them, the universe has effectively reached its final thermal state. And in this state, the cosmos is quiet beyond imagining, illuminated only by the faint memory of light. As the universe drifts deeper into its far future, one process continues unfailingly: expansion. Space stretches, gently and endlessly, carrying galaxies, particles, and even photons farther apart. What began as a rapid burst after the Big Bang evolves into a slow, persistent widening, a quiet unfolding of the cosmic fabric itself, and with each stretch, the universe grows colder. Expansion is not like objects moving through space. It is space itself growing. The distance between points increases even if nothing travels. Galaxies move apart not because they are fleeing one another, but because the stage beneath them is swelling. In the early universe, this expansion was countered by gravity, which drew matter together into stars and galaxies. But in the far future, with most structure dissolved and gravitational anchors weakened, expansion becomes the dominant force. The result is profound. Everything drifts away from everything else. Imagine dots drawn on the surface of a balloon. As the balloon inflates, each dot grows farther apart from the others. Nothing pushes them. The surface itself expands. The universe behaves similarly. Over trillions of years, distances stretch to scales almost beyond comprehension. Particles that once might have collided now drift apart forever, separated by widening oceans of empty space, and with this expansion comes cooling. As space grows, the energy within it spreads thinner. Photons lose energy, their wavelengths stretching until they become faint, cold whispers. Matter grows more isolated. The temperature of the universe approaches absolute zero, not reaching it, but drifting ever closer in an endless approach. This infinite cold is not sudden. It is a slow dimming, a gradual thinning, like the fading warmth of embers long after a fire has burned out. Each era of the universe adds to the cooling. The end of starlight, the evaporation of black holes, the dissipation of matter. With every step, the cosmos moves deeper into a quiet equilibrium where heat has nowhere left to flow. Eventually, expansion becomes so extreme that even the idea of distance changes. A single particle may find itself effectively alone within its observable region, with everything else too far away to influence it. Light from one part of the universe can no longer reach another. The horizon of what is visible shrinks around each fragment of matter, forming isolated pockets of existence floating in boundless dark. Yet there is no violence in this isolation, no shattering, no tearing, just a peaceful widening. The universe relaxing into an ever larger, ever colder state. It is as though the cosmos is inhaling slowly, endlessly, letting its boundaries drift toward infinity. Infinite expansion leads to infinite cold, a state where change grows so rare and energy so evenly spread that time itself becomes almost indistinguishable from stillness. In this vast silence, the universe settles into its final gentle trajectory, one defined not by brightness or heat, but by the quiet embrace of endless space. As the universe expands into deeper and deeper stillness, a curious boundary begins to appear, a horizon not of land or sea, but of possibility. This boundary is shaped by distance, by the fading of light, and by the simple fact that space grows faster than anything can cross it. Beyond a certain point, regions of the universe slip away from one another, not by motion but by expansion itself. This is the horizon of nothingness, a subtle threshold beyond which connection becomes impossible. In our current era, we can observe galaxies millions or billions of light years away. Their light reaches us despite the vast distances because the expansion of space has not yet carried them too far. But in the far future, the story changes. Expansion accelerates. Regions of space drift apart faster than photons can bridge the growing gap. Eventually, most galaxies, and then all galaxies, disappear from view. From any given point in the late universe, the observable cosmos shrinks. Slowly, the lights go out, not because they fade, but because their light can no longer keep pace with expansion. It's like watching ships sail over the curvature of the Earth. They do not vanish suddenly, but slip gently beyond the horizon. In this era, isolation becomes the defining feature of existence. A lone particle may drift in a region of space so vast and empty that nothing else lies within reach, not even in principle. Its observable universe becomes a tiny bubble floating in an immeasurable ocean. Beyond that bubble, everything recedes into unreachable darkness. This horizon does not mark a boundary of the universe itself, only a limit on what can be known or influenced. Space continues to exist beyond it, expanding and thinning, but communication across that threshold becomes impossible. Information cannot pass, light cannot cross, even gravity loses its reach. The horizon of nothingness is not a wall, it is a quiet fading. Imagine walking into a thick fog. The world does not end where visibility fails, yet your connection to it dissolves. The universe experiences a similar dissolution, with each region becoming its own secluded island of existence. Within these isolated pockets, what remains continues to cool and drift. Without contact or exchange, each fragment of matter follows its own slow path toward equilibrium. There is no drama in this separation, only a deepening calm, a widening silence. And in this silence, the universe reveals something profound: connectivity. Once the engine of cosmic change gently gives way to solitude, the bonds that held galaxies together loosen. The pathways for light to travel narrow, then disappear. What remains are small, quiet domains surrounded by an infinite expanse where nothingness grows. The horizon of nothingness is the universe's final boundary, not of space, but of interaction. Beyond it lies the unreachable, the unlit, the forever distant. Information is the hidden thread woven through everything in the universe. It is encoded in the position of every particle, in the pattern of every star, in the arrangement of molecules, and in the memories held inside a human mind. Information gives structure meaning. It is the difference between order and randomness, between a galaxy and a cloud of drifting atoms, between a thought and a silence. But in the far future, as the universe cools and smooths into equilibrium, this thread begins to fray. Slowly, gently, the universe approaches a time when information itself fades. Information requires contrast, differences in energy, patterns in matter, variations in temperature. But in a universe moving toward heat death, these contrasts disappear. Every region becomes nearly the same as every other. Energy spreads evenly. Movement slows, structure dissolves. With each step, the capacity to store or transmit information diminishes. In earlier ages, information flourished. The spin of electrons encoded atomic structure. The sequence of DNA carried the instructions for life. The orbits of planets traced out cosmic stories. Even the glow of distant galaxies held the memory of how matter clumped and flowed across time. Everywhere, the universe was full of meaningful patterns. But as entropy rises toward its maximum, patterns become rare. A lone particle drifting through the cold cannot carry much meaning. It has so little energy, so few interactions, that its state barely changes. And without change, information cannot be written or read. Photons stretch into wavelengths too long and faint to preserve the details of their origin. Even the last traces of temperature differences fade, leaving almost nothing for future processes to encode. Some theories suggest that even the remnants of information once stored inside black holes, information about the matter that fell into them, may ultimately disperse through Hawking radiation. If so, the universe in its final ages becomes not only cold but forgetful. The archives of cosmic history dissolve into a mist of faint random particles. Imagine a book exposed to wind and rain for thousands of years. At first, a few words smudge, then whole lines fade. Eventually the pages crumble into dust, carrying no trace of the story they once held. The universe experiences a similar erosion, not through weather, but through expansion and entropy. Yet this fading is not tragic. It is the natural completion of a long process. Information emerged because the universe once held gradients and structure. When those gradients vanish, so does the capacity to preserve detail. What remains is not destruction, but a profound simplicity, a return to a state where nothing distinguishes one place from another, where existence becomes an endless, gentle sameness. The end of information marks the universe's final quieting. Without patterns, without memories, without contrast, the cosmos settles fully into equilibrium, a calm so complete that even the concept of before and after loses meaning. In this deep stillness, the universe becomes a perfect whisper of what it once was. Memory is a kind of pattern, a gentle arrangement of information held in place long enough for meaning to arise. In a human mind, memories take the form of electrical pathways and chemical traces. In the universe, memory appears in the way particles arrange themselves, in the glow of ancient starlight, in the structure of galaxies, in the fossil imprints of cosmic events. Every pattern is a form of remembrance. But as entropy rises and the universe slides toward equilibrium, these memories slowly soften, blur, and eventually fade. Entropy, in many ways, is the great unspooling of cosmic memory. When energy is concentrated, patterns can form, atoms bind, stars ignite, organisms think and dream. But when energy spreads evenly, patterns become harder to maintain. Warmth flows into cold, order drifts into randomness. Over time, complexity dissolves into simplicity. Memory requires distinction, and distinctions fade as entropy climbs. Early in the universe's history, memories were everywhere. The cosmic microwave background carried the imprint of the Big Bang. The arrangement of galaxies reflected the ripples in primordial matter. The stars held memories of their birth clouds, and planets carried the history of countless collisions. Life evolved in response to its environment, learning and storing information across generations. Even your own mind holds patterns shaped by moments of joy, sorrow, curiosity, and wonder. But in the very distant future, when stars are gone and atoms rarely meet, the universe becomes a quiet field with almost no ability to store detail. Photons, stretched by expansion, lose the energy needed to encode meaningful information. Particles drift so far apart that interactions, the basis of memory, practically cease. The universe becomes smooth not only in temperature but in the stories it can carry. To imagine this, think of a footprint on a beach. For a moment, it is clear, each ridge and curve preserving the memory of a step. But as the tide rises, water gently fills the impression. Sand shifts, edges blur. Soon, the footprint disappears, not torn away but softened into the shore. Entropy is that tide moving across the cosmos, gradually smoothing the stories written in matter and light. And yet, this perspective is not bleak. The beauty of memory lies not in its permanence, but in its presence. The universe had an era where it could remember, where it could form galaxies, ignite stars, nurture life, and contemplate its own existence. Entropy does not erase the wonder of these moments, it simply carries them to rest. As the cosmos moves toward equilibrium, memory gently releases its hold. Patterns fade, not as losses, but as part of a natural, peaceful return to simplicity. The universe forgets because it no longer needs to hold anything. It has reached a state where nothing changes, nothing strains, nothing requires recollection. In this quiet softening, memory completes its arc, just as the universe completes its long journey toward calm. Consciousness is one of the universe's most delicate forms of order, a temporary arrangement of molecules, energy, and memory capable of perceiving itself. It arises only in narrow windows where conditions are just right. A warm star nearby, a stable planet, a complex chemistry, a flow of energy that sits comfortably between too much and too little. In the vast timeline of the cosmos, consciousness is a flicker, a spark glowing between long stretches of darkness and stillness. To understand its fate, we return to the idea of gradients, differences in energy that allow processes to unfold. Minds exist because these gradients drive metabolism, thought, and sensation. Stars warm planets. Chemical reactions generate electrical signals, Neurons fire, carrying patterns that become experience. Without gradients, consciousness cannot arise. It depends on contrast, warm and cold, charged and uncharged, active and resting. But in the far future, gradients fade. As the universe expands and cools, temperatures equalize. Energy spreads thinly. The conditions needed for thought, or for any dynamic process, disappear. No warmth to power a brain. No chemical flows to sustain perception. No structured matter to host complex networks. Eventually, consciousness as we know it becomes impossible. This does not diminish the beauty of consciousness. If anything, it makes it more precious. In a universe governed by entropy, the emergence of self-awareness is a remarkable exception, a brief island of complexity in a sea trending toward simplicity. We are part of that exception. Every thought you have is a product of gradients that the universe once supported with abundance. Some theories speculate whether new forms of consciousness could arise in the far future, perhaps in exotic systems or artificial substrates. But even these would require energy flows and stable structures, two things the universe steadily loses as it approaches heat death. In the deep twilight of cosmic time, matter becomes too dispersed and cold to support the intricate dance of information that consciousness requires, and so the fate of consciousness is not a dramatic ending, but a quiet fading. Over trillions of years, minds become rarer. Over even longer spans, they vanish entirely. Not because something destroys them, but because the stage on which consciousness performs, the warm, structured, energy-rich universe, gradually transforms into a smooth, quiet field where no such performance is possible. To imagine this, think of a candle flame. Its light is bright, warm, meaningful. But it exists only while fuel remains and air flows. When the conditions change, the flame does not shatter, it simply goes out, leaving darkness behind. Consciousness too is a flame, beautiful, impermanent, arising from conditions that will not last forever. Yet the universe remembers in its own way that consciousness once existed. It remembers through the atoms rearranged by life, through the photons emitted by our technology, through the stories and signals we have cast into space. Even if those traces fade, the fact that consciousness ever appeared is a profound moment in the cosmic story. In the long arc toward a stillness, consciousness is a brief but brilliant awareness, a way the universe looked back at itself before drifting into calm. Loneliness, as we understand it, is a human feeling, a quiet ache that comes from missing connection. But the loneliness of the far future is something different. It is not emotional, for there will be no minds left to feel it. Instead, it is a structural loneliness, a universe where distances grow so immense and matter so sparse that every particle exists in practical isolation. It is a solitude woven into the fabric of space, a quiet that deepens with every passing trillion years. In our current cosmos, the universe feels full. Galaxies cluster in webs, stars form in glowing nurseries, and planets circle their suns with rhythmic grace. Even the vast spaces between galaxies hold particles, fields, and the faint glow of ancient radiation. There is emptiness, yes, but it is an emptiness rich with presence and possibility. But in the far future, this fullness slowly dissolves. Expansion stretches the universe so dramatically that objects once close enough to interact become forever separated. Light from distant regions can no longer reach others. Gravity weakens with distance until it can no longer pull structures together. The cosmic web, once vibrant and interconnected, thins into distant islands adrift in an ocean of nothingness. Imagine drifting alone on a raft in endless waters, unable to see any shore or star. The universe becomes something like that, except even the raft is shrinking, and the waters are expanding without limit. Each remaining particle or remnant is carried on its own path, never touching, never encountering, never exchanging information again. But this cosmic loneliness is not sorrowful. It is serene. There is no longing, no loss, only separation, vast and gentle. The universe is simply easing into a state where contact becomes impossible, where distance grows beyond the reach of light itself. This solitude also marks the end of interaction. Without encounters, nothing new can form. No atoms collide, no stars ignite, no galaxies merge. The dance of creation slows, then stops. What remains is a collection of isolated particles drifting into an endless horizon. Each one experiences its own quiet existence. But without the possibility of connection, the idea of togetherness dissolves. In this sense, loneliness of the far future is not something to mourn. It is a natural outcome of expansion and cooling, the universe finding a kind of peaceful detachment, a soft release from complexity, a settling into the simplest possible state. And perhaps this cosmic solitude mirrors something within us, the understanding that connection is meaningful precisely because it is temporary. Just as stars shine for a time before fading, relationships, memories, and moments of togetherness glow briefly in the long stretch of time. They matter because they are short-lived. In the far future, as loneliness becomes the universe's quiet default, we're reminded of how rich the present truly is, a time when connection is not only possible, but abundant. Silence, as we know it, is never absolute. Even in the calmest room, you might hear your breath, the faint hum of distant life, the pulse of your own heart. In nature, silence still holds the rustle of leaves or the murmur of wind. But the silence of the far future universe is something far deeper, a quiet so complete that even the concept of sound becomes irrelevant. This is silence beyond silence, a stillness that stretches across space and time. When the universe was young, it was anything but silent. Nuclear reactions roared in the hearts of stars. Supernovae erupted with unimaginable force. Galaxies collided in titanic bursts of motion. Even the faint glow of cosmic radiation hummed with energy and potential. Sound itself may not travel through space, but the processes that created light and structure were filled with dynamic, chaotic motion. But as the cosmos ages, all of that motion softens. Stars burn out, gas cools, black holes evaporate, matter thins into a scattered mist. Eventually, there are no events left energetic enough to ripple the universe with noticeable change. The processes that once filled a cosmic history with brilliance fade one by one, until the remaining energy becomes too spread out to drive any meaningful transformation. Silence beyond silence is not simply the absence of noise, it is the absence of activity. Imagine a vast field of snow stretching infinitely in every direction. No footsteps, no wind, no shifting shapes, just stillness, untouched. Now imagine this calm expanding to the scale of the entire universe. Every particle drifts in near-perfect isolation. Every photon moves with so little energy that it barely interacts with anything. Every region of space becomes identical to every other, a soft equilibrium with no contrasts left to spark change. In this deep stillness, even time becomes difficult to sense. Without events, without motion, without transformation, the measurement of moments loses its purpose. There is no before or after in any meaningful sense. The universe no longer experiences cycles or rhythms, it simply exists. And yet this profound silence holds a strange beauty. It is not a harsh emptiness, but a tranquil conclusion to a long dynamic journey. The cosmos has weathered fire, turbulence, creation, and collapse. It has hosted galaxies, stars, planets, and consciousness. It has pulsed with light and motion for billions of years. Now, after its long voyage, it rests. This silence is the universe's final meditation, a calm that follows eons of activity. Not a void, but a moment of infinite stillness, a silence deep enough to cradle the memory of everything that came before. In this quiet, the universe reaches a kind of peace that words can barely describe. Silence not as absence, but as the purest form of equilibrium. As the universe settles into its final stillness, a gentle question floats at the edge of thought. Is this truly the end? Heat death paints a picture of ultimate calm, an equilibrium where no energy flows, no structures form, no processes unfold. It is the universe in its quietest state, a vast expanse with no gradients left to drive change. But physics is a deep and mysterious ocean, and even in this serene horizon, possibilities linger like faint ripples beneath the surface. Some theories suggest that the heat-death state is not an absolute ending, but a kind of cosmic pause. Quantum mechanics, for example, allows for fluctuations, tiny random tremors in the fabric of space. Even in near-perfect stillness, these fluctuations might momentarily create pockets of activity. They are minuscule and rare, but the far future is infinitely long. Given enough time, even the smallest possibilities accumulate into potential stories. One such possibility is the idea of a Boltzmann brain, a spontaneous temporary configuration of particles forming a conscious mind, not out of intention, but out of statistical chance. But these hypothetical minds would be fleeting, unstable, and isolated in a universe with no structure. They would arise without context and vanish without memory. More poetic than plausible. They remain interesting only as thought experiments, glimpses into how strange infinity might become. Other theories imagine that new universes could bud off from our own. In some cosmological models, space itself can experience quantum fluctuations large enough to trigger a new expansion, essentially a new Big Bang in a disconnected region. If true, heat death might not be final at all, but simply the quiet after one universe's story, while countless others blossom elsewhere beyond observation or influence. There are also conjectures that the laws of physics might shift over unimaginable timescales, subtly altering what is possible in the deep future. These ideas are speculative, but they remind us that the universe has reinvented itself many times, from radiation to matter, from simplicity to complexity, from darkness to light. Perhaps reinvention is embedded in existence, even if we do not yet understand how. Yet for all these possibilities, the simplest scenario remains the most serene. The universe reaches equilibrium and rests there indefinitely, neither beginning nor ending anew. A quiet, eternal calm. Whether heat death is the final chapter, or merely a page before something unexpected, one thing is certain. Uncertainty itself is part of the cosmic story. The universe has always surprised us, with its birth, its structure, its laws, its deep beauty. Perhaps its ending too carries room for wonder. And so, instead of fearing heat death, we can view it as the universe's ultimate exhale, a moment of profound stillness that may hold both closure and possibility. The universe is often imagined as a place of stars and galaxies, but beneath all its luminous details lies something more fundamental: change. From its first blazing moments to its final drift into stillness, the cosmos has been shaped by transformation. Motion, heat, gravity, light. Each has told part of a long evolving story. And while heat death may represent the quietest chapter, it is still part of that same unfolding narrative. In the beginning, change was abrupt and fiery. The infant universe expanded with unimaginable speed, energy condensed into matter, and matter organized into clouds that collapsed into stars. Galaxies formed, stretched, collided, and reshaped themselves. Every second was charged with creation. Every corner of space was alive with new structure. Later came subtler changes, Stars aging, planets cooling, galaxies slowing their dance. Life emerged on at least one tiny world, its consciousness capable of reflecting on the cosmic story itself. Even this was a form of change, a local reversal of entropy, powered by the steady flow of energy from a nearby star. The universe, through living beings, briefly learned to observe its own evolution, and then, after billions of years, the great arc shifted direction. Change began to slow, stars dwindled, galaxies dimmed, matter dispersed. But even this slowing is not an ending. It is a continuation of the universe's movement toward balance. The cosmos changes by becoming more even, more uniform, more still. In a way, heat death is simply the final expression of change. Not a dramatic transformation, but a gradual smoothing, a soft release of structure back into simplicity. The universe once changed through fire. Now it changes through quiet. Imagine a river. At its source, water rushes with youthful intensity, carving landscapes and leaping over stones. But as it approaches the sea, its flow widens and slows. The river has not stopped changing. It has simply reached a different phase of its journey. It becomes calm, expansive, accepting. The universe follows a similar path. Its early turbulence gave rise to the splendor of stars and life. Its late tranquility reflects not failure but evolution. The cosmos is moving toward equilibrium because that is the natural outcome of its laws, a final, gentle settling after ages of dynamic growth. To see the universe as a story of change is to understand that every phase, from the brightest to the quietest, belongs to the same narrative. The endings are connected to the beginnings. The stillness is connected to the fire. Even the far future, empty and calm, is a continuation of the same cosmic flow that once produced galaxies and consciousness. Heat death does not erase the story, it completes it. And in that completion, the universe reveals its deepest truth. Everything flows, everything transforms, everything finds its way toward balance. The cooling of the universe is one of the simplest truths in cosmology, yet also one of the most poetic. From its earliest moments, the cosmos has been losing heat. Not abruptly, not carelessly, but like a warm breath released into a cold room. This cooling is steady, patient, and inevitable, guiding the universe through every stage we have explored. To understand why the universe cools is to understand not only physics, but also the quiet rhythm that carries everything toward stillness. In the beginning, the universe was unimaginably hot. Energy crowded into every inch of space, dense and radiant. But as the universe expanded, that energy stretched and thinned. Space itself grew larger, and with each increase in volume, the temperature fell. This was not a cooling caused by loss, but by dilution, warmth spreading out across a growing canvas. Imagine a cup of hot tea poured into a vast ocean. The heat does not vanish. It disperses, becoming less concentrated, until it is indistinguishable from the temperature of the water around it. The universe behaves similarly. As space expands, light loses energy, wavelengths stretch, and the overall temperature trends downward. Another reason the universe cools is the absence of new heat sources. Stars once replenished cosmic warmth by forging elements and releasing immense amounts of light. But as star formation slows and suns die, the universe gradually loses its engines of heat. Energy continues to flow outward, but far less is generated. The processes that once rekindled warmth, nuclear fusion, gravitational collapse, matter-antimatter interactions, all diminish with time. What remains is the gentle background glow, photons stretched into cold microwaves, drifting endlessly through space. Over trillions of years, this glow becomes even fainter, its temperature approaching absolute zero without ever reaching it. Cooling also reflects the increase of entropy. The universe moves towards states where energy is evenly distributed, where no pockets of concentrated heat exist to drive new cycles or create new patterns. As entropy rises, gradients flatten. When no warm place remains beside a cool one, the flow of heat ceases. Yet this cooling is not bleak. It is a natural part of cosmic evolution. Just as a day cools into night, or a fire settles into embers, the universe cools because it changes, because it moves, because it follows the quiet logic of its own laws, and there is something gentle in that. The cooling universe is not collapsing or dying, it is relaxing. It is unwinding from its earliest intensity, settling into equilibrium after ages of brilliance and complexity. To understand why the universe cools is to see the beauty in its long arc, a story that begins in fire and ends in calm, a story where warmth gives way to stillness, not as loss but as completion. There is a quiet beauty in things that do not last. Stars burn brilliantly, then fade. Galaxies swirl for ages, then soften into mist. Even entire epochs of the universe rise and fall like gentle tides. From our human perspective, impermanence can feel unsettling, a reminder that nothing remains the same forever. Yet in the cosmic story, impermanence is not a flaw, it is the very essence of beauty. When something passes, it creates space for change. When a star exhausts its fuel, its death scatters elements that may one day form planets, oceans, and living beings. When a nebula collapses, it gives birth to new light. When galaxies collide, they reshape themselves into new patterns, more intricate than before. The universe is never static. It lives in motion, in transitions, in the soft turning of one chapter into the next. Even the fading of the cosmos into stillness holds its own calm beauty. The flow of heat into cold, the gradual quieting of stars, the long cooling of matter, these are not abrupt endings but gentle dissolutions. The universe is not extinguished. It is transformed into a state where everything rests. Like a candle burning low after a long night, the dimming is peaceful, unhurried, and tender. Impermanence also deepens meaning. We cherish sunsets because they do not last. We treasure certain moments precisely because they cannot be repeated in exactly the same way. In the same vein, the era of stars is precious because it is finite. The time when galaxies glow brightly, when planets orbit warm suns, and when life can emerge from stardust. This is a rare interval in cosmic history. It is beautiful because it is brief. The future calm of the universe does not erase this beauty. It highlights it. Knowing that stars will one day fade makes their present radiance even more profound. Understanding that complexity will eventually soften into simplicity makes the complexity we witness now all the more astonishing. Even on Earth, the most meaningful experiences often arise from impermanence, a wave that forms and dissolves, a season fading into the next, a life composed of countless moments that never pause. The universe mirrors this pattern on a grand scale. It teaches us that passing is not an ending but a part of the flow, and so, as we imagine the universe drifting towards stillness, we can hold on to the beauty of passing things. Not as losses, but as transitions. Not as disappearances, but as quiet transformations. The cosmos does not hold its brightness forever, and that is precisely what makes its glow so extraordinary. Life is a gentle warmth in a cold universe, a fleeting spark that appears only where conditions are just right. It requires energy flowing from one place to another, gradients of temperature, chemistry arranged in exquisite patterns. Life is not the default state of matter. It is a rare and remarkable exception. In the grand timeline of the cosmos, it shines for only a moment, and yet that moment carries profound meaning. Consider how life emerges. A star burns, sending out heat and light. A planet forms at just the right distance, not too hot, not too cold. Complex molecules assemble in warm oceans or simmering vents. Slowly, over ages, these molecules begin to copy themselves to respond to change, to evolve. From these humble beginnings, consciousness arises, the universe briefly becoming aware of itself. All of it depends on warmth. Energy must flow steadily but gently, powering the cycles that allow organisms to grow, move, think, and dream. Too much heat and molecules tear apart. Too little, and chemistry freezes. Life thrives only in the delicate balance between extremes, a temporary pocket of order in a universe that otherwise trends toward disorder. But warmth is temporary. Stars that nurture life will one day exhaust their fuel. Planets will cool. Energy gradients will fade. Even the most resilient forms of life cannot survive in a universe sliding toward perfect equilibrium. Over the farthest stretches of time, life becomes rarer than impossible. The cosmic conditions that once allowed biology to flourish drift away like a fading season. Yet the temporariness of life does not diminish its significance, it amplifies it. Life is precious precisely because it is fragile, because it depends on fleeting circumstances, because it shines brightly for a moment against the dark backdrop of cosmic history. Imagine holding a small flame cupped in your hands. The flame is warm, alive, always moving. You know it cannot last forever, but while it burns, it illuminates everything around it. Life is like that flame. It lights up the universe not with heat alone, but with curiosity, emotion, creativity, and awareness. Through living beings, the cosmos experiences beauty, wonder, and reflection. Even if life exists only during one brief phase of cosmic time, its impact is profound. It transforms matter into meaning. It turns stardust into stories. It gives the universe a way to appreciate its own complexity before it softens into calm. In the distant future, when warmth fades and life becomes impossible, this temporary glow will remain part of the universe's history, a chapter of astonishing intricacy in a story that stretches towards stillness. Life is temporary warmth, but in its briefness, it is extraordinary. Meaning is something we often imagine as eternal, a truth that should last forever. But in a finite cosmos where stars fade and memories dissolve, meaning arises not from permanence, but from presence. It grows in the brief intervals when consciousness appears, when life reflects on itself, when matter briefly arranges into forms capable of wonder. The universe does not need to last forever for its moments to matter. In the early cosmos, meaning existed only in potential. Hydrogen and helium could not think, feel, or interpret. But as stars forged heavier elements, as planets cooled and chemistry blossomed, meaning took shape in the minds of living beings. On one small world orbiting an ordinary star, the universe learned to question itself. It learned to observe its own beauty. Sunrise over oceans, starlight through atmosphere, the quiet pulse of a living heart. Meaning was never written into the laws of physics. It emerged through experience, through beings capable of curiosity, empathy, creativity, and awareness, through stories told by warm minds living in a universe slowly cooling. Even though consciousness is temporary, the meaning it creates is real, not because it endures forever, but because it exists at all. The finiteness of the cosmos deepens, rather than diminishes this significance. If everything lasted forever, then nothing would be precious. But in a universe where stars burn for only a while, where galaxies drift apart, where life flickers briefly in sheltered pockets of warmth, the rarity of these experiences gives them weight. A finite cosmos teaches us that beauty is not diminished by impermanence. The glow of a star is meaningful because it will eventually fade. The existence of life is remarkable because it emerges against long stretches of stillness. Even consciousness, brief as it may be, reveals something extraordinary. That matter can contemplate itself, that the universe can become aware of its own unfolding story. Meaning does not survive the universe's deep future. It does not persist into the cold equilibrium of heat death, but it does not need to. Meaning belongs to the era in which it arises. It belongs to the beings who feel it, to the thoughts that form, the emotions that ripple, the connections that deepen. Meaning is a local warmth in a cooling cosmos, and just as stars shine not forever but beautifully, meaning glows brightly for as long as consciousness endures. In that glow, the universe becomes more than a physical system. It becomes a story, a moment of awareness, a brief flowering of understanding. A finite cosmos still holds infinite meaning, because meaning is not measured in time, but in depth of experience. Impermanence is woven into the universe at every scale. Stars ignite and fade. Galaxies form, drift, and dissolve. Even the laws that shape matter lead inevitably towards stillness. Nothing in the cosmos remains unchanged forever, and yet there is a gentle wisdom in accepting this, a calm that comes from recognizing that impermanence is not a flaw, but a natural rhythm, the quiet pulse underlying all existence. As humans, we often long for permanence. We want the moments we cherish to last. We want the skies to remain familiar, the people we love to stay beside us, the world to hold still just long enough to breathe. But the universe reminds us that everything flows. Change is the constant that shapes reality. And through that changing, beauty emerges. A star is beautiful because it burns only for a time. A sunset is precious because it fades. A life is meaningful because it unfolds in a limited span, shaped by choices, emotions, and connections that exist only once. Impermanence gives weight to experience. It asks us to notice, to appreciate, to savor. The cosmos itself follows this principle. It began in fire, blossomed into structure, and will eventually settle into calm. Each phase is temporary, each phase necessary. The brilliance of galaxies depended on earlier chaos. The rise of life required ancient stars to die, and the future equilibrium of the universe is simply another transformation, a final smoothing after a long journey of contrast. To accept cosmic impermanence is to understand that the universe is not losing anything. It is flowing from one state to another, just as it has always done. The heat death is not a failure. It is a natural conclusion to a story shaped by expansion, cooling, and entropy. A peaceful settling after ages of motion. Even on Earth, impermanence teaches us to live fully. Seasons change, tides rise and fall, days turn to nights. These rhythms guide the rhythms within us, our breaths, our thoughts, our lives. The universe, on its vast scale, mirrors the truth we already feel in our hearts, that change is not the enemy of meaning. It is the canvas on which meaning appears. There is serenity in embracing this cosmic truth. When we accept impermanence, we allow ourselves to move gently with the flow of time, rather than resisting it. We learn to appreciate the fleeting warmth of life, the fragile brightness of consciousness, the delicate balance that allows us to wonder about the universe at all. Impermanence does not diminish the cosmos, it enriches it. It reminds us that existence, even temporary existence, is an extraordinary gift, a moment of light in an ocean of time. As we drift toward the end of this long cosmic journey, it becomes clear that the universe's story moves in a great gentle arc. It begins in intense heat and dazzling expansion, unfolds into structure and light, blossoms briefly into life and consciousness, and eventually returns to quiet, even stillness. This arc is not a circle in the literal sense. The universe does not repeat itself, but it carries a sense of completion, a soft rounding of the cosmic narrative. Reflecting on this journey brings a feeling of calm perspective. The universe has never been static. It has been flowing since its first moment, reshaping itself through eras of fire, growth, cooling, and dissolution. And throughout this long flow, meaning has emerged in the most unexpected places. In the birth of stars, in the chemistry of oceans, in the thoughts of conscious minds capable of wonder. In this reflection, we see that the universe's fate is not separate from its history. Heat-death is not a deviation, but a natural continuation of the same processes that formed galaxies and life. The cooling that leads to stillness is the same cooling that once allowed matter to form, stars to shine, and planets to become cradles of complexity. When we look backward from the quiet of the far future, the earlier universe appears vibrant, almost musical. Each galaxy a note, each star a chord, each conscious being a brief but beautiful melody. Over time, those melodies soften, then fade, until the cosmic song settles into silence. But the silence is not empty. It is full of the memory that something once sang. This full circle perspective also offers a gentle reminder about our own place in the story. Our lives occupy a moment so brief compared to cosmic time that it could seem insignificant. And yet, when we reflect with care, we see that our awareness, our connections, and our small acts of meaning are part of that vast arc. We are expressions of the universe, brief flourishes of structure and warmth before the cooling resumes. Just as stars do not shine forever, neither do moments. But while they last, they illuminate. They give shape to experience. They allow us to feel the flow of time, the texture of existence, the wonder of simply being here. In contemplating the universe from beginning to end, we are gently reminded that transience does not diminish beauty. Impermanence does not reduce meaning. The cosmic journey is richer because it changes, because it flows, because it carries everything toward calm. The arc of the universe is a soft exhale, and we, fleeting but aware, are part of that breath. And now, at the end of this long and gentle journey, we drift into the final horizon of the universe, the soft landing of heat-death. This is not an ending marked by collapse or fire, not a dramatic finale, but a quiet settling. A smoothing of everything that once was structured, warm or bright. The cosmos arrives not with a farewell, but with a slow exhale, releasing the last traces of contrast into an ocean of calm. In this distant future, the universe becomes a place of near-perfect balance. Temperature equalizes across unimaginable distances. Energy spreads so thin that no new stars can form, no galaxies can take shape, no patterns can arise. The gradients that once powered the drama of creation dissolve into a gentle uniformity. What remains is a vast, tranquil field where nothing strains or seeks or transforms. Heat-death is not destruction, it is rest. The final rest of a universe that has lived through fire and brilliance, through growth and gravity, through life and thought. Every atom, every photon, every memory created along the way is woven into this soft quiet. The cosmos does not vanish, it simply becomes still. Imagine floating in a silent sea under a sky without stars. There is no fear in the darkness, only release. The currents are calm. The horizon stretches endlessly, untouched. The universe in heat-death feels like that, a gentle, infinite quiet, where nothing aches to change anymore. And though no minds remain to witness it, this stillness carries meaning. It reflects the full arc of cosmic evolution, from the explosive birth of space-time to the glittering ages of stars, to the introspective dawn of consciousness, and finally to the serene equilibrium of everything that follows. Heat-death is the universe returning to simplicity after an eternity of complexity. For us, imagining this final calm brings perspective. Our moment, this life, this breath, this single night of listening is part of that vast cosmic flow. Temporary, yes, but deeply precious. Against the backdrop of an eventual still universe, the warmth we feel now, the connections we hold, the thoughts that flicker in our minds, all become extraordinary. They exist only in special pockets of time, when the cosmos is bright and alive. And so we close this journey not with sorrow, but with gratitude. Gratitude for a universe capable of light. Gratitude for the brief windows where stars burned and consciousness arose. Gratitude for the chance, however fleeting, to wonder. As the universe lands softly into its final equilibrium, we too can let ourselves settle, breathing gently, resting in the knowledge that everything follows its natural flow. Everything flows. Sleep in that motion,